Good afternoon, ladies and gentlemen. Thank you for attending our July 31st Improving Talk. Before we start, I want to introduce you to a feature in the presentation that will make the session a bit more interactive. Please note the Q&A icon at the bottom of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send the moderator questions to be delivered to our insightful presenter at the appropriate time. Speaking of insightful presenters, we have one today sharing a webinar titled Data to Knowledge to Insight to Action, Walking the Path of AI Values. Our presenter is a Christian, father, husband, passionate geek, and lifelong learner who serves as the Chief Consulting Officer of the Improving Enterprise and President of the Houston office. He's one of the US leaders in artificial intelligence, spending countless hours mentoring executives on how to leverage AI and ML tools to support their organizations properly. In his development days, he was a Microsoft MVP for 6 consecutive years while co-authoring a book with one of his best friends. Shout out to Tim Reber, that's the best friend. And also, Don't Sleep on Entity Framework 4.1, the Expert's Cookbook. It is still available on Amazon. Shifting to a business-centric focus on improving, he has won numerous awards, including the Vistage Leadership Award, and is named one of the most admired CEOs in Houston. While leading his organization to over 100 Best Places to Work awards in North America and being ranked #1 in Houston the last 4 years as Best Places to Work, and that's 100% guaranteed because I was there. I know we won all those. He is a drummer, a lover of dad jokes, the AV guy at his church, a ballroom dancer, a footballer, a gamer, a woodworker, father of dragons, and keeper of the realm we call the Houston office. Ladies and gentlemen, I'm pleased to introduce you to my good friend, Devlin Lyles. Devlin, the floor is all yours.
Thanks, Sherman. If you've never heard an introduction that catches you entirely sideways and puts a grin on your face, you should get to know Sherman, because I didn't know half of that was going to be in there, and it brought joy to my life. So Sherman talked about some of this already, but this is who I am, but it doesn't tell me at all. It doesn't tell you at all why you should care about my opinion when it comes to data, or why you should be listening to Improving on this. So I want to kind of highlight a couple of those pieces. One is that over the last 5 years, Improving has done a lot of projects for our customers. And those projects have netted over $4 billion with a B in net returns for those customers. So beyond the cost of doing the AI and machine learning projects, a significant value return, whether that was in increased oil production or decreased cost or value optimization for pricing structures and procurement. The returns are generated differently. But one of the things I hope you hear out of this is a focus on business value. And we're going to drive through that for the next 45 minutes to an hour together. The other side of it is my background. I was a software developer by trade and training. I kind of grew into the data space, and I spent 20 years building kind of large-scale data and analytics platforms, whether that was midstream oil and gas or custom retail or manufacturing. That's really where my background lives, and then kind of the consulting game spread that out for me. Any conversation that includes AI has to include a conversation around the hype cycle, because we see over and over and over again that the overpromise of AI has left a lot of people either believing it can do magic, which is dangerous, or believing that it can't do anything, which is equally as dangerous. The overall usage of AI is increasing, and the values created from that in businesses for efficiency and those kind of things is increasing. Gartner's hype puts generative AI at the peak of inflated expectations today. I think we're still on our way to that peak, but we're significantly closer than I thought we were 6 months ago. And so this is continuing to evolve. The trough of disillusionment is going to come in a time in which people believe that AI can do something. They've been promised that AI could do something for them, but it's not actually going to achieve those results. And you may have heard this of, AI is going to get rid of jobs. That's one of those inflated expectations. Now, there are some jobs that AI is going to get rid of. I don't want anybody to hear that it's not going to have any impact. I'll give you an example of one of those. Prompt engineer. Prompt engineer is one of the jobs that AI is going to get rid of. And it sounds funny and it sounds counterintuitive, but just like in the 1970s, the late 70s, early 80s, when computers were just coming into the back office workspace and those kind of things, we had a title that showed up on the scene of people were being hired to be computer operators. Now, I want you to imagine where you work today. If every time you needed to interact with a computer, you went to the computer operator and they computered the things you needed to. What we realized is while this is a specialized skill, it's an easily trained specialized skill to teach everybody how to interact with computers. And so we ended up having 30, 40 years of office and productivity suite training and basic computer programming, basic computer interactions, and even programming. And that started trickling back into our educational system. So now elementary and middle school kids interact with computers all the time. We're going to see that same evolution in the AI space. We're going to see AI trickle back into every role in the back office, in the white collar roles and those kind of things, and even then into blue collar work and into our educational system. Prompt engineering, the idea that you're going to have to learn how to talk to AI via chat systems and those kind of things is real. It will be a part of almost every job in our industry over the next 3 to 5 years. It will be just as expected as being able to use Outlook or Gmail or Google Sheets or Excel. You're just going to be expected to have this tool in your toolkit. And so while AI will change jobs, very few jobs will just go away entirely. Now, one of the things that we're going to start separating, and hopefully I'm going to give you a framework by which you can kind of separate these things, is we've all been doing things with this new technology, whether that is experimenting and playing with it and having it write rap lyrics for your D&D campaign, or writing a Valentine's card for your spouse or significant other. That's ad hoc usage of a technology. Improving uses our technology adoption framework to help companies move past that, because most folks get distracted by the strategic and transformational. They get distracted by all of the shiny what if of new technology, like a new product or service offering that your company could bring to the table, or all this data that you have historically that you could monetize by creating an AI SaaS platform when your core business is manufacturing. While those things may be true, typically the best value to go after in the short term is around efficiency gain. It's around labor compression. Can I do the job we do today faster, better, cheaper? And so that's where experimentation comes in. Now, the key difference between just doing stuff and experimentation is a few things. One is you have a rigorous methodology, right? The scientific method, you have a structure, you have a way to interact with it that has controls built into it to make sure that you don't have invalid assumptions. The second is you have a hypothesis to test. You believe AI will have what benefit in your business. And then you have a way to measure that outcome. If I believe AI is going to save me time, I need a way to measure whether it saved me time. And then the last step, and it's the one almost everybody misses, but is critically important, is then publishing those results, sharing your learnings with the rest of your team. Because if you had a failed experiment where you didn't verify your hypothesis, you can save other people from making that same investment to not get a result. Inside your team, if that's playing with Excel to overcome a certain barrier or do some analysis faster, you're like, hey, I tried it, it doesn't work that way. Awesome. You just saved everybody the time of that investment. And if you succeed, you also then allow them to replicate that and magnify the efficiency gains that come from it. And so AI needs to be targeted based on those hypotheses, and those hypotheses need to include a return on investment. Now, I'm going to step way back and talk about how we've evolved as a society, because I think it'll inform how we move forward, but it's also going to tell you what institutional scar tissue we have to overcome. Now, the first is we've gotten really good over the last 50 years in capturing and storing large amounts of data. We would capture them. We built custom software to capture them. We have CRMs. We pay for SaaS products, and we capture all this. Now, as we got more and more data, we started working through reporting and exception management and like, hey, I want to see profitability monthly, which used to take a lot of work to put together. Now it's faster and easier. I want to see exception management for projects that aren't profitable, those kind of things. And then it started moving closer to real time, right? Before that, it was all retroactively looking, typically a month or a quarter or a year in retrospect. And so we started getting closer to real time. Real-time processing gives us the ability to manage those exceptions while we can still do something about them. Pardon me. That real-time processing also creates some interesting problems, because when I allow data to settle, right, data at rest is data that it's already been through, it's not midstream, it's kind of a complete picture of that data. Whereas real-time processing, I'm having to deal with things like incomplete pieces of data and dealing with analytics based on those incomplete pieces because the process isn't done working yet. And so we started tackling this in the late 90s, early 2000s, and it really expanded from these hyper real-time systems into, when I say hyper real-time, systems in which the information is invalid a few seconds afterwards. Think about like algorithmic trading platforms in the financial space, into kind of further and further expanding the definition of now, where you're able to look at real-time processing as everything that happened within the last 5 to 10 minutes, real-time and near real-time processing. We started looking at this stream of events, this stream of information coming through and going, hey, I can actually predict some of what's about to happen, right? And that's where that predictive analytics came in. And this was highly focused on value cases, like predicting whether a commodity is going to move up or down, or predicting a yield curve, those kind of things. Once we had those predictions, we then could go, well, what if I change something? And we could make prescriptive action where it's like, hey, if this is the outcome I want, and this is the trend I'm seeing, here's what I can do to change it. And so you start going, hey, here's our predicted pricing, sales, margin, etc. And this action will increase sales or margin based on some of that what if scenario. And that's where you get into the prescriptive action. So this is what we've been doing for the last 50 years as that kind of progressed. AI doesn't change this. And I want you to hear that very clearly. AI doesn't change this. These are still the biggest steps of that capture and usage. What it does, however, is change how we do this information. So on the right here, I want to talk about something that we use internally. This is the improver skill density, right? So if I look at across all of improving, we've got a lot of folks. And so we largely need to know, hey, who's got these skills when we're building project teams and those kind of things. This is a scheduled, summarized, and aggregated set of reporting. That first step of, I know what insights I want, I just need them to be regular and applicable. The speed of ingestion and data readiness becomes the primary constraint. In this, data veracity becomes a question. And so AI impacts these systems by, one, making the reports easier to get to, because you can do things like cluster analysis, and you can do deeper analysis into those known insights, but also in helping you to make sure your data is clean and ready. There are metadata extraction systems and data pipelines that will allow you to overcome these things. All of that is targeted at reducing the data engineering costs for bringing these tools to market, right? So previously, my data reporting and data warehousing and exception management might have taken 2 to 3 data engineers. And now it takes 1 to 2 data engineers, because they're leveraging some machine learning techniques and AI techniques to shorten that cycle and make those things repeatable. If I'm analyzing inbound data and I'm looking at it and going, okay, about a third of the time an exception case, because they've misspelled something or it's a different format of document or something like that, AI can help me to soften those edges around it. And you heard about some of this in our kind of month before today of webinars in that data platform engineering space. If you haven't taking a look at those. They're on our YouTube channel. I would definitely take a look at it. As we pivot to enhancing that, the idea behind this is that we can gain value in the chain all along on the route. And so AI in this space can help us to detect anomalies in data, missing data, and then normalize it either by filling it in with aggregates or by being more flexible in how we structure our contracts for like semi-rigid or semi-structured data versus fully structured data in our data warehouses, data lakes, data lake houses, data beach houses. I think the water analogy in the data space has probably gone too far, but I'm looking forward to my data river boat. The step past that kind of known intelligence is exception management. It is the idea that I can take those known insights and go, all right, there are times when something has gone wrong. Now, I threw together some example projects in our test environment and went, how do I know when something's gone wrong? Now, we define the barriers that we want to constrain with, and we can do that via hardline business rules, traditional BI approach. With machine learning and AI, one of the things we can do is detect exceptions that those hardline business rules potentially wouldn't have detected before. So you can do things like anomaly detection. How many of these things don't look like the other things? And you don't have to rigidly define those business rules. You can use anomaly detection algorithms. You can do sliding window analysis. So inside this window of events, this thing looks wrong, even though it wouldn't look wrong if I averaged it across a year. In this one instance, it looks wrong because it was a 15% increase over the previous measurement or those kind of things. And so we aggregate this data and then start looking for those exceptions. What it allows us to do is inform a human more readily to going and taking action on that. It's not going to solve the problem, but that extraction of information and the elevation to human is about then taking action. And so this is trying to turn that data collection into knowledge, which is what that BI piece allows us to do. This is then going, hey, and here's some insights. Here's some data that might have been hidden that isn't hidden any longer. What are you going to do about it? Now, improving approaches these steps, and I kind of break these as these two steps are traditional kind of data engineering, business intelligence, data warehousing. We approach this in kind of 5 steps, right? In ingestion, there are tools and techniques that you can use to enhance data, to extract data, to structure metadata around things. Now, this ingestion pipeline in the AI space, if you're looking at documents and semi-structured, could be vector, so embeddings by creating a vector database of the words and densities that are inside a document or inside a data set. And then you're going to verify against it. What you verify against that ingestion is verifying that you were able to extract the things you wanted to extract. Verify that you were able to enhance the data in the way you expected. And we're going to hear more about this over the next few weeks as Scott Poulin dives into decoding the AI riddle. Kevin Jourdain is actually going to walk through RAG architectures and then hopefully into graph RAG architectures that do some of this ingestion and metadata analysis as a part of the RAG. And then even in the computer vision space with Eric Grog and the reasoning applications, you heavily rely on metadata enhancements that Mike L is going to talk about a little later this month. And so you get this verification loop of the verification is, can the data I ingested serve the thing I'm going to ask to do with it? So if I'm importing a large swath of data and I've got 20, 30% of that requires human intervention to clean it up, maybe I apply machine learning or an LLM or statistical analysis to reduce that. So instead of 30% of my records requiring human intervention, 5% require human intervention. And that labor savings allows me to ingest more data quickly. Now that cleanse step is about cleaning up known bad data. This could be fat fingers. My favorite example of this is in CRM data cleanup. Duplicate records or records that are invalid, right? If I'm working on like contact relationship management, I do have to be able to contact the person. So if I have a record that's just a name, no email, no phone number, that's invalid to the purpose that it's in. And so you can do some of that cleanliness and verification. Now, interestingly enough, this cleanse step can be removal from the data set, or it can be enhancement, right? Of going, hey, this is a person entered by this other person, right? So let's say Bob was entered by John, right? And so I go and I look at John's network via graph analysis or LinkedIn or whatever, and I go, oh, I found Bob, and I add the contact details, the LinkedIn details, these kind of things. So cleansing can do remediation, or it can do removal. It's like, yeah, we have no idea who Bob is, just delete Bob's record. That's a huge amount of human effort. And so by leveraging AI network cleanup, deduping tools that use machine learning, largely speaking, and kind of data correlation, we can enhance that data without having to remove it. Because when you're removing data in the cleanse space, you're losing the insights that were covered in that data going forward. This is true in the cleanse space around like medical records and production records. Is, somebody's handwriting production records, they may misspell something. And so you go through and you clean up those kind of things. There are different techniques to use in that space. Now, once we have that cleaned and verified and enhanced data, the next step for us is going to be transformation of that data. And so like canonicalizing into a known format that we can aggregate, share, report on, etc. That transformation has largely traditionally been done by a deep expert in the kind of data transformation space, the data warehousing space, and you still need that expert. AI's play and machine learning's play in this transformation is that canonical version can be more flexible, right? Because I can design systems that are significantly more flexible by leveraging AI in that design and implementation phase. I can use semi-structured and unstructured data and report on it at almost equal levels because the tooling is not as constrained, right? SQL Server and those kind of BI tools traditionally relied on the schema definition, the structure of the data, to gain insight from the data. Whereas with unstructured tools and leveraging machine learning and LLMs and some of the embedding models that we talked about for ingesting and cleansing, that transformation can happen in near real time, given some of these pipelines, but also it can infer significant additional steps beyond without having to rely on a structured schema that is immutable. And then aggregation, we find that this is about, complex calculation, those kind of things. And so the statistical models, machine learning and deep learning models work really well for doing things like unknown exploratory aggregation, where you don't know what aggregates it's going to create, but it's going to show you patterns in consumer behaviors and those kind of things. The aggregations it shows you in that exploratory realm allow you to then provide human insight on top of it. And we're going to dig into one of those case studies here in just a minute. The aggregation on the structured side, the non-exploratory, is about making repeatable aggregation that has softer edges around the workload. One of the things we do at Improving is we aggregate the amount of projects we're doing based on our expertise or practice areas. And we say, okay, these are our app modernization projects, and these are our business agility projects. But projects are rarely that clean, right? They typically include app modernization and data, business agility and process. And so using that kind of more flexible aggregates for things like fuzzy matching and those kind of things allows us to get a better output for less effort. And we start seeing some of that return on investment in that data engineering gain. And so on this whole path, when we go kind of insight backward in traditional data warehousing data work, you see how AI can accelerate and enhance every one of those steps so that you can get to that business outcome, both via the labor savings of doing this work, but also in making the outcome significantly more flexible. And so we break this up into kind of backward looking so that we can then move forward looking. But what I want you to hear from this is traditional garbage in, garbage out. I spend 3 years building a data warehouse. That's being challenged heavily by the machine learning and AI space of these machine learning and AI enabled data platform and data engineering toolkits. It does not at all remove the need for highly skilled data engineers and data analysts and data scientists. What it does is it accelerates their efforts so you can get the business value much faster without having to ingest, cleanse, and transform all of your data. You can start in vertical slices and then mutate over time because the tools have gotten better in dealing with some of those ambiguity and some of that change by compressing labor and using these kind of machine learning and AI enabled tools. Now, the trick to everything we've talked about so far is understanding what insights you're looking for. So I want to dive into kind of where we're at and how you can then apply this to your value cases. Now, we're going to talk in generalities, right? I love this picture because it gives you kind of an overview. We're going to focus on kind of the big pieces. So supervised learning is when you knew the answer in the past and you believe the past will represent the future. And so things like, hey, I'm going to look at population growth over the last 200 years, and I'm going to predict population growth over the future. Or I'm going to look at project profitability over the last 5 years, and I'm going to, then apply that model to the future and go, is this project going to be profitable? Supervised learning works really well when you have labeled data sets of known provable fact. Provable fact being that you say, this is everything that happened and this was the outcome. Whatever that is, right? This picture is a cat, or this project was profitable, right? Those kinds of things. So supervised learning allows you to do things like identifying fraud and doing diagnostics because it's painting the past onto the future and going, hey, this deviates from the pattern I've seen in the past. Reinforcement learning is a lot like my 11-year-old. So when we were teaching our 11-year-old to clean his room, we did it with him for a while, and then it was like, hey, go clean your room. 5 minutes later, he'd come downstairs, all done. Nobody believed him because he just put it under the bed or in the closet. And so you'd go up and you'd open the closet door and you go, hey, that's not clean. And then, 10 minutes later, all done. It's like, okay, bookcase looks good, but you just moved everything from in the closet to under the bed. That doesn't count. And so you get these micro feedbacks of something you did well, something needs improved. And through hundreds of these cycles, we taught them what good looked like. Now, I could have written out everything expected and tried to remember all of the edge cases and error scenarios, etc. But that list would have been really long and probably not super helpful in doing the job. And this is where like traditional rules engines and those kind of things can be overcome with reinforcement learning. Is once we've trained him what good looks like, we can go to my parents' house and be like, hey, go clean up the game room. It's not the room he was trained in. It's not the furniture, it's not the toys, and yet he knows what good looks like in cleaning the room. We do the same thing with computer systems. Reinforcement learning is used in robotics to train walking models. It's used to train driving models. It's used in a lot of simulated environments to teach the system how to deal with these individual outcomes rather than having to code for every outcome, because coding for every potential variant becomes so cost prohibitive that you can't do it. And so in that machine learning space, reinforcement learning is when you make a financial prediction on that project, and then you go back and you go, yep, that prediction was valid. Nope, that wasn't. And you can create this reinforcement loop to allowing it to gain better insights over time. Now, my last and favorite one in these is unsupervised learning. Now, I'm going to dig into the complexities of unsupervised learning because it can consider more things than normal human labor has time and effort available to consider. It doesn't mean it's going to come up with like mind-blowing answers. So let's take a look at some kind of value churn. So traditional analysis would go, hey, here's this, linear regression. This is where we're losing customers, and one size fits all. There's some human insight to it. You can do this in Excel today. If I take machine learning on that same data set, it represents clusters of risk for customers. Now, what I want you to see is the original arc is accurate. It's just not precise enough. You'll see that the hotspots at the top of the graph pull the arc up. The hotspots in the bottom right pull the arc down. But there's some missing insights in that. There's clusters that were missed. And so when you start making decisions on fairly rudimentary analysis, you're going to make okay decisions because you don't have the precision to make great ones. In the analytics space, when we talk about traditional BI, this is largely where machine learning helps us, is to better understand things where we've got okay systems for them today, and we need much better systems for them tomorrow. Now, that evolution requires this whole transactional difference. And this is improving kind of information to decision intelligence matrix that we walk through. You'll notice governance and security is at every level of this. Data quality, discovery, master data management, none of that goes away. I don't care how advanced the analytics you're using. I don't care what AI models. You have to be able to do everything on that top bar. It's some level, because otherwise the data becomes unreliable, and then your insights from that data become unreliable. Now, we've talked about acquisition and persistence. Let's talk about some of the more advanced analytics pieces. Now, predictive analytics are pretty crucial for data-driven decision-making. The idea that I can take current and historical data, apply machine learning to it, and then forecast trends and behaviors. The trick is making sure that these behaviors matter to your business, right? Can I predict with reasonable accuracy when I will go get coffee every morning by recording that and tracking my behavior? Yes. Will that change the outcomes for improving overall? Not really. Now, can I predict when a customer is likely to buy from us or likely not to? Maybe. And that could have significant outcomes for improving. And so it's about picking the right problem and then leveraging some of these forecasting trends and behaviors over time. That incentive focus towards ROI and differential will help you in picking the problem space that you're trying to drive from. Now, once you have the problem space of the insight you want and the action you want to take, right? I want insight of when is a customer likely to need improving before they've told us they need us, so that I can reach out to them and help them with whatever problem they're working on. Then I start going back down the chain that we've talked about for the first 20-ish minutes of, all right, so now I need the data, ingestion, aggregation, all of those things. And I start walking back from that. Here's the decision point I'm looking to get to. Here's the intelligence about that decision I need. And I walk back and I make sure that I've checked all the boxes on that ingestion, cleansing, transformation for those data sets. That's that approach backwards that I can then leverage machine learning and some of those tools to accelerate the efforts. But none of that's worth doing unless the decision I'm trying to get to can actually make an impact to our business. Now, that may not always be easy to discover. The way we typically do this is we look at where we're spending labor. Where are we spending hours? That's the first question. If it takes me 30 hours to do something and I have to do that thing monthly, and I can, by leveraging machine learning, by leveraging AI-enabled tools, I can take it from 30 hours to 5 hours. That's awesome. That saves me 25 hours a month. So over a year, we're talking about saving me basically 300 hours. That 300 hours then can be reassigned to more productive work. But imagine I find something that takes me an hour a day and I can get it down to 15 minutes. It's going to give me way more than my 300 hours because it gives me the output. 2 hours a day to 15 minutes gives me way more than my 300 hours. Now, most of those tasks that you're doing in that space, you start looking at ways to accelerate it, whether that is in building some of the pre-intelligence models here, right? Whether that is in capturing and doing analytics, that largely we've left that advanced analytics side of this equation to humans. We've progressed our automation structures in acquisition and persistence and visualization closer and closer to not needing a human, right? I can go into Excel, I can crack a bunch of data together, and then I can visualize it by inserting a chart and those kind of things. I can create KPIs in Power BI or in Tableau. But we've largely left those advanced analytics, those understanding and discernment analytics to humans. And it takes a long time when you got that raw data to then put it into a format and a structure and a visualization that allows you to look for patterns, look for predictive analytics, or look for predictive things where it's like, oh, when this happens, these other things happen. And so the predictive side of this is picking those times where making the decision faster will actually help you get there. That pivot to business insights of, okay, so if I can get to this decision faster, then the follow-on processes can also go faster. And that's where we're aiming to get to. Now, those business insights are not going to be, hey, Devlin, you should reach out to that customer today. It takes a lot of evolution to get to that level of here's exactly the action you should take. And rarely are you going to need to make that level of investment. It's pretty fast to get to, here are the 15 most likely customers that you haven't talked to in the last 6 months that are reasonably likely to buy. And then you decide what to do after that. And so human discernment doesn't go away, and you're likely not going to just magically get the answer out of the machine learning box. What you will get is the insights that then make better decisions. Enhancing your decision-making for better outcomes is actually significantly better of a target when you're talking about machine learning than trying to replace the decision-making of the human. This is back to that hype cycle. It's over-promising to say AI will make better decisions than a human all the time. But informing better decisions, it can almost always do. And that's where that interactive participation really matters. So as we dive into this, one of the things I wanted to do was leave some open time for everybody to kind of bring some questions to the table. I know Shervin remarked on this earlier. What are some places that you're looking at that you're like, hey, how would you approach this? Now, I pinged a couple of customers and got some of these, so I'm going to start with those, but I'd ask you, go to the QA in the webinar chat, and let's get some questions loaded while I go through some of the others. So the first question I got was, I don't want to spend $500,000 to get this insight. Does that mean I'm waiting to jump on the AI train? The answer is absolutely not. Almost nobody is building their own algorithms. There are a few companies, and don't get me wrong, they're great, that are doing a ton of research and they're building out price prediction algorithms and those kind of things. The vast majority of enterprise AI use cases are going to leverage off-the-shelf, openly published algorithm sets and off-the-shelf LLMs to then either fine-tune them or zero-shot tune them, or even just prompt tuning and engineering and orchestration to get the outcome you're looking for. And by doing that, by avoiding the R&D cost and using those kind of free researched algorithms, you're reducing your cost to engage in the kind of AI space and gain value out of it by 75 to 90%, right? It doesn't cost you multiple millions to research a new AI algorithm and test it against the market and try and create a price prediction algorithm. You can leverage a price prediction algorithm and get a project out there for 100 to 150,000 instead of 1.5 to 2 million. And so you get that cost compression when it comes to the overall project by leveraging off-the-shelf tools. Now, the encouraging part about that is that it also allows you to leverage your existing teams and your existing knowledge. If I'm a developer that is working on application development today, I can start learning and leveraging machine learning into my applications without having to learn new languages, because we've taken some of those kind of well-tuned algorithms, we as an industry have taken those well-tuned algorithms and built them into frameworks like ML.NET for the C# and .NET developers out there, or deep learning for J for the Java developers out there. There are JavaScript, TypeScript, Python, C#. There are tons of libraries that make this approachable for an application developer to start learning this new toolkit. Almost every application is going to have some chunk of it that would actually be faster and easier to leverage AI than it would be to write the business rules traditionally. And so you can lower your costs by leveraging those off-the-shelf components, similar to the way you'd use open source software today, to accelerate software development. Now, the other question that I've gotten ahead of this is I'm reading my notes. How can AI help me if it can't get the answer right every time? Imagine AI as computer labor. It's an intern that works for you 24/7. What processes would you put around to verify the output of that intern? The output of that intern would likely get reviewed by a senior that understands the workload, et cetera, and edit it a little bit, maybe some feedback to the intern, and then you'd use that output. You're going to do the same thing with AI, because even if it's accurate 85% of the time, that's 85% of the time where it's taking you a lot less labor to do that work. And so I use AI often to assist me day to day, but I never just use it and then out the door. It is about making sure that it's appropriate, it's reasonable, it matches what we're looking for in its outcomes. And so it's an accelerant to my work, but it's not a replacement for my work. And you're going to have to approach managing AI in the same way. AI may give you an answer, but it's going to give you an answer in the confidence level. So machine learning will say, I'm 99% confident that this pattern matches this pattern. It's not going to say absolute certainty. And so what you end up having to decide is, what level of confidence are you okay with, right? The same thing when somebody estimates a, construction of a house or a software project. That's not a guarantee that that's the answer. It's an estimate, and that estimate has a certain level of confidence to it. You're going to treat an estimate with a 50% confidence different than one with a 90% confidence. You're going to have those same control systems and mechanisms when it comes to the kind of AI systems in front of us. So I'm going to pause here and go, Shervin.
A couple of questions for you, Devin. Our friend Josh asks, any tips for sourcing talent in AI engineering in a way that cuts through the hype from candidates?
It's a great question. So I don't know that I'm going to give you a popular answer, but I'm going to give you my answer. So hype from candidates, whether it's in AI or emerging technologies, can largely be conquered by talking about actual productivity. What systems have you taken to production? I was just on a call earlier today saying the differentiation between research data scientists and enterprise data scientists is the level of engineering competency to build repeatable systems. Because getting an algorithm working on my laptop is very different than publishing a production system with that full data ingestion and data engineering and data governance pipelines, and actually dealing with process for data cleanliness. Because on my machine, I can make it look like the data is always perfect. And so when we're interviewing for AI and engineering talent, we go deep into what have you actually done and taken to production? Because there's some folks that are great at the conceptual level, but then can't actually execute on it. And it separates those candidates pretty quickly when you're like, okay, so what's your favorite Python library for doing that, right? The folks who are just kind of hype are going to have a struggle for that answer, or they're only going to have one answer. Like, okay, if you couldn't use that, what would you use? Like, if you can't use pandas, what would you use? And you start understanding the level by which, have they just played with a few of the pieces, or are they really kind of engaging in the engineering discipline? The second one is start asking them how they test the validity of their models. It's another one of those things that almost nobody thinks about unless they've actually had to deal with these systems in production environments. How am I measuring accuracy, false positives, false negatives? How do you optimize for your false positive, false negative rates? Because in some cases, a false positive is a significantly better outcome than a false negative. Imagine that you're doing a cancer prediction model. False negative means they don't go in for a biopsy and it doesn't get diagnosed and you potentially put them at risk. Whereas a false positive means they had to get a biopsy. They might have been scared and anxious for a while, but the test will come back and say, hey, it wasn't cancer. And so in that case, you want to actually lean towards false positive because the risk of a false negative is significant. So when you start asking these AI engineers in the market today, what their validation approach is, what harnesses they've used for validating, how they've tuned for false positive, false negative, you cut through the hype really quickly and find what they've actually been able to accomplish. Hopefully that gives you some good tips for the finding really good AI talent. It is a challenge in a hype-based market, but those are some tools that we use.
Devlin, we have another question. It says, with the metaphor of an intern that has direct oversight or filters, does this mean you wouldn't recommend AI having direct surface area to your customer or users?
I don't mind AI having direct surface area to customers or users. And largely in some business cases, it makes sense. What you do want is a similar level of review or kind of overview and QA that you would have for a human with that level of connection and oversight to your customers. Give you an example. We talked about interns, but imagine a customer service rep who's chatting with your customers through your website. There's review processes. We analyze transcripts for things like cuss words and recommendation errors and conversion rates, and you measure and manage the performance of that person to some business output, some goals, right? That everybody they talk to is either converted or rates the conversation a 4 or 5 on a 5-star scale. Like, we've got measurement systems when it's a human talking to our customers. You want the same level of oversight when you have a computer talking to your customers. Are you measuring your AI systems based on 4 and 5-star ratings the same way you would a human? Are you measuring the AI on conversion rate, right? Are you scanning its transcripts to make sure it's not saying what you don't want it to say? So it's not that you shouldn't have surface area to a customer, but that you should treat that customer with the same diligence, regardless of whether it's a computer-based tool or if it's a human doing that work. Now, the ways you manage it are going to vary pretty drastically, but the need for managing it doesn't change between the two. Well, I greatly appreciate everybody taking an hour out of your day. I'm going to kick this back over to my good friend Shervin and let you conquer back a few minutes on your calendar and enjoy a walk outside.